Hey, welcome! Today we're going to get under the hood and take a look at a piece of engineering magic you rely on every single day, but probably never even think about. We're talking about the car alternator. It's the real unsung powerhouse of your vehicle's electrical system, and we're about to break down exactly how this incredible device works.
So let's just start with a basic question. Think about your car. You've got headlights, a sound system, GPS, probably dozens of computer sensors. Where does all that electricity actually come from when the engine is up and running? Now, if your first thought was the battery, well, you're only about half right.
Okay, let's clear this up right away, because it's a super common mix-up. The best way to think about it is like this. The battery is a sprinter. Its job is to provide that massive jolt of energy, that spark, to get the engine cranking. But once you're on the road, the alternator takes over. It's the marathon runner, providing all the continuous power needed to run literally everything else.
And that really gets us to the heart of the matter, the car's big power problem. You see, a battery all by itself will get drained incredibly fast trying to keep a modern car going. It's just not built for that kind of constant heavy load.
So what is an alternator, really? Well, in the simplest terms, it's your car's own personal power plant. It's a generator that cleverly takes the mechanical, spinning energy from the engine, usually through a belt, and it converts it into electrical energy. That's what keeps your car alive and all your gadgets running.
And it's basically juggling two jobs at once, and both of them are absolutely critical. Job number one is powering all your electronics while you're driving. Job number two, and this is so important, is recharging the battery. It's constantly topping it off so it has enough juice to start the car the next time you need it. Without the alternator, your battery would just go flat, and your engine would eventually just quit.
All right, so let's pop the cover off this thing and meet the key players inside this little power plant. It turns out there are four main components that work together in this beautifully coordinated dance to make all the magic happen. First up, we've got the rotor. This thing is really the heart of the alternator. It's connected to a pulley, which is spun like crazy by the engine's belt. Now, when a little bit of electricity is sent to it, it becomes a powerful electromagnet, and its one and only job is to spin and create a powerful moving magnetic field.
Now, wrapped all around that spinning rotor is the stator. Unlike the rotor, this part doesn't move at all. It's just a stationary bundle of very tightly wound copper wires. And as the rotor's magnetic field spins and sweeps past these coils, something amazing happens. Electricity is generated right there inside those wires.
Okay, but here's the catch. The electricity that's created in the stator, it's actually the wrong kind for your car. It's something called alternating current, or AC. But your car's battery and all its electronics need direct current, or DC. And that's where the rectifier comes in. You can think of its diodes as a series of one-way electrical gates that basically force all that electricity to flow in just one single direction, converting it from AC to DC.
And finally, we have the brain of the whole operation, the voltage regulator. This little electronic circuit is constantly keeping an eye on your car's electrical system. Its job is to make sure the alternator doesn't get carried away and produce too much or too little voltage. It's the bodyguard for all your car's sensitive electronics.
So, we've met the whole crew. We have the rotor, the stator, the rectifier, and the regulator. Now let's see how this team works together to turn simple spinning motion into stable, usable electricity. It all boils down to a fundamental principle of physics that was figured out by Michael Faraday, and it's called electromagnetic induction. And what it means is actually pretty simple. If you move a magnetic field past a wire, you will create an electrical current in that wire. That's it. That's the secret behind pretty much all electrical generation on the entire planet.
And here's how it all comes together in your car in 4 simple steps. Step 1, the engine's belt spins the rotor. Step 2, that rotor's powerful magnetic field slices through the stator's copper wires, creating raw AC power. Step 3, the rectifier immediately gets to work, flipping that unusable AC into usable DC. And finally, step 4, the voltage regulator steps in and fine-tunes that power to a nice, safe, and steady level, somewhere between about 13.5 and 14.5 volts.
And trust me, this whole AC to DC conversion thing, it's not just a small detail, it's absolutely critical. And here's why. The alternating current that comes out of the stator has electrons that are flowing kind of chaotically, forwards and backwards. But your car's battery and all its complex computers and electronics, they need a smooth, steady, one-way flow. And that's exactly what direct current gives.
This quote really highlights just how important that little voltage regulator is. Just think about it for a second. The faster your engine spins, the more voltage the alternator naturally wants to pump out. So without that regulator acting as a gatekeeper, Hitting the gas pedal on the highway could send this massive power surge through your car, and it could literally fry everything from your stereo to your headlights to your engine's main computer.
Now, all this works beautifully in the background, until it doesn't. So how can you actually tell if your car's personal little power plant is starting to have problems? Let's go over some of the most common warning signs.
Okay, first and foremost, the most obvious one is that little battery warning light popping up on your dashboard. That's your car screaming for help. But there are other clues that are a bit more subtle. Pay attention to your headlights. Do they seem to dim when you're idling at a stoplight and then get brighter when you accelerate? You might also notice your electrical stuff acting weird, like power windows that seem really slow. Also, listen. Listen for any strange noises, like a distinct whining or grinding sound coming from under the hood. And of course, the classic sign, if your battery just keeps dying, even right after you've had it jump-started, the alternator is almost always the real culprit.
So there you have it. The alternator isn't just another part. It's this incredibly elegant, self-regulating power system that really makes modern cars possible. It's just a perfect example of this hidden genius that's packed into everyday engineering. And it kind of makes you wonder, right? What other complex, brilliant systems are hiding out there in plain sight, all around us?